Hi, my name is Jay Clark. I'm an AI ML specialist at AWS. And in this video, I'm going to take you through an application for ingesting, summarizing, and turning into podcast research papers or research articles. So I'll start with just sort of showing you the application in full. Then I'll go through each of the pieces, show you the major functions, and then I'll end with a bit more information on how I use prompts to then elicit the right results, right? And this is using some generative AI applications or some generative AI models, and I'll show you how I make use of those. So first, just a bit about this. I spend a lot of time trying to read papers. My time is short, so I can't always go through them fully. And what I was really looking for was something that would summarize papers, give me useful information from them. And I had seen a lot of and follow a lot of YouTube channels and the like that, like 2 minute papers and other things like that. So I thought it would be interesting if I could make that for myself, right? So I don't have to necessarily wait until a paper is finally there. I can sort of choose the papers that I use. So that's this AI Research Digest. I'll give a bit about what's happening on the back end. Basically, what it's designed to do is take PDFs, extract the text from them, and then pass them into a generative AI service to then be summarized and get some other information, but not just summarized. I mean, summarization is fairly standard at this point. What it's also designed to do is give me some more actionable information. So, for example, something that really helps me gain a grasp of new techniques, new models, etc., is to see code. And so one aspect or one thread of this is to turn the paper or the full text into a code example. Another aspect is that I'm not always able to read the summaries. Sometimes I'm on the move. I don't have access to my computer necessarily. And so the other aspect is to then turn these into sort of podcasts, right? Or audible versions of the paper. And the key distinction between sort of a text summary and I guess I'll call it a transcript is that I learn things differently depending on the medium, right? So it wouldn't be enough for me to have just a text generated summary read to me, right? We want something a bit more in depth, a bit more designed or targeted towards someone listening to it. And I'll show the prompts that I use for that. So the general diagram is I have data in storage. It's a PDF. I will be using AWS services for obvious reasons. And so Textract is a service designed to just take in documents and extract text from them, PDFs in this case. That's then fed into Amazon Bedrock. It's our generative AI service that makes a ton of foundation models available for use to then go through each of those individual processes. So you see the three documents here, essentially a text summary, a code summary, I'm using air quotes there, and then a transcript to then be turned into an audio recording or podcast. And then I'm using Amazon Poly to then use its text-to-speech feature to then turn those transcripts into my podcasts. Finally, just some what this is running on information. So EC2 is sort of where this is designed to run on, but for this example, I am running it through Amazon SageMaker just for ease of development. And I'm using Streamlit because that's the popular thing right now. And then additionally, I'm storing essentially the metadata information into a DynamoDB table. So what does it look like to use this? So the approach would be you have a paper, and I have a paper here. So supervision transformer, something I saw a while ago that I was interested in learning a bit more about, increasing the computational or decreasing the computational costs of vision transformers. And we'll just download the paper. I've already downloaded it. And on the left-hand side, there are some file upload options. And I'm just going to browse some files and upload this paper. And so once I upload this, it'll just go into an S3 bucket, the stuff set up on a back end, and I'll show some of the pieces of setting that up as well. And now, if I want to actually get this paper summarized, I'll load the available papers. There are the unprocessed papers and the processed papers. For the unprocessed papers, I have a couple of pieces here, but this is the PDF we just uploaded. And then I can summarize that. And so because it takes a couple of seconds, I'll just start that summarization and give you a bit more information. So there's some parameters that we set as well. So when we talk about data input and output, if you recall all of these buckets, so all of these are named so that you can choose a different location if you'd like. Not the biggest deal, but worth noting. And then additionally, the model. So what model am I using? Right now, and for this, I use Anthropic's Claude, mostly because of its long context window. Some of these papers, I think the Vision Transformer paper was like 20 pages, but for some of these papers to get into the 50 to 100 pages, you need something that can handle that context, and Claude can. And then there are a couple of other versions that I experiment with. Additionally, the max generation length. So this is for each of the individual pieces, right? So the max length for the summary to be generated, the max length for the code to be generated, the max length for the transcript and podcast, / podcast. And then temperature, I set it low just for consistency reasons. And then I've shown you the file upload, right? You can upload a file, but additionally, you can just place your PDFs into the S3 bucket and also point it to that, and that's fine as well. So it's going through the process. This should be finished in a few seconds or so, but the text is probably at this point been extracted, and then it's been sent to the Anthropic model to then get back our summary and code and podcast, and then the podcast is generated as well. So hopefully this will take not too long, or not too much longer. And if it does, I may just pause the recording and then show back up when it's done. Okay, and so that has completed. And the way you know it's completed, on the right hand side, there's the sort of paper breakdown section. I'll close this, give us a bit more space. And if you open this up, there are a couple of pieces here. There's the audio session of the podcast that I'll play a little bit from in a second. Then we have our paper summary. So this is the textual summary, just background, the data that they use, the models, their solution, results, etc., and then future work, novel contributions. But as well, I attempt to generate a code implementation, what they've done, and so I'll just sort of glance at this. So we have the super vision transformer, class token, encoder layer, transformer. Okay, it seems reasonable. Obviously, I'd have to do a bit more work to just make sure that's implemented correctly, but I can start experimenting with this. This can give me a better idea of what the paper is implementing. And then a bit of the podcast session. So I'll play, maybe not the whole thing, but I'll play a little bit of this.
The title of this paper is Supervision Transformer. This paper was released in 2021. There are 5 authors of this paper, with the lead author being Mingbao Lin. The most relevant categories for this paper are computer vision, image recognition, vision transformers, and model compression. This paper summary discusses a new method to improve the efficiency of vision transformers for image recognition. Vision transformers work by splitting an image into patches, representing them as tokens, then modeling dependencies between the tokens. However, capturing dependencies using multi-head self-attention is very computationally expensive. The key idea here is to train a single vision transformer model that can operate at different levels of complexity. This allows the model to trade off accuracy and efficiency at test time based on the available compute resources. The authors accomplish this by training the model on two types of variability. First is multi-size image patches, splitting the input image at different granularities. Second is multi-token keeping rates.
I'll stop it there. I think you get the idea. So, interesting. I would say the key feature to note is that the audio session, although it goes over the same information as the paper summary, isn't a verbatim of the paper summary, right? It's not an audio version of bullet points, which I think is the useful bit here, right? If I'm not looking at a paper, if I'm listening to what a paper is presenting, then I need that to be sort of explicit in a sense, and I need a bit more understanding, for lack of a better word. But so we have that paper sort of processed. Additionally, we have any of the previous papers that have been processed, obviously including the one we just processed, and so we can choose a couple of these here. So these have already been ingested, and we'll pull these up. Yeah, so we have retrieval augmented generation for code summarization, retrieval augmented code generation, and we have a similar thing. So there's an audio session, there's a paper summary, looks pretty good, as well as a code summary. And there's one that looks like it's missing a title. Okay, the audio session's here. Fine-tuning code example. Transformer layer, LoRa layer. Okay. Maybe this is a LoRa paper where maybe the title didn't get saved into the database the way it's supposed to. But long story short, we have these papers, and then we can listen to these audio sessions, or download them and turn them into an actual podcast. So this is the application. How does it work? Right. So I will jump into SageMaker and show the code. SageMaker isn't a requirement here, but this is where I do a lot of my coding. And there is a fair amount of code in this, but most of it isn't major, or most of it isn't sort of a requirement of doing this sort of summarization. And our connection code to store things into S3, pull things from DynamoDB, a lot of the orchestration is what I'll say. Maybe one of the pieces that I'll sort of mention first is I do have a configuration file that I usually use. And so this is more specific to sort of Streamlit. When I'm running Streamlit apps, my general process is to pass in whatever my variables are as configurations. So that'll be things like what region I'm working, what data stores I have access to. In this case, S3 is a big one, so I have my bucket and any of the prefixes that I'm working with. The models that I'm using, I will have a name for them, a display name, as well as the actual endpoint itself. And then, so here's the DynamoDB table that I'm using. And then I have a diagram, and so I just have the path to that diagram. And not super interesting, but just something I use to keep myself organized. So here's where the actual code is. And I will stop on the functions that matter. Or maybe I'll give a bit about all of them. So this is just initializing any of the session state information. I make use of this a lot. But there's some just sort of text, the about me's, architecture details, application details. So, great text, please read it, but, not super important here. And then here's the function that actually does the processing of the configuration file. And so it just passes back a config object, but really just takes that JSON and turns it in, standardizes the names, as well as creating these sessions, right? So the way I generally interact with AWS services is with Bodo 3 or with the Bodo library. And here I get S3. Here I'm using Poly. I'm using the Bedrock runtime, as well as Textract and DynamoDB. And so I'm just initializing those clients and passing them back. So here's when we get to sort of the first oops, instance of me making calls to language models. I'll actually start with, well, okay, I'll start with model tags. So when I'm creating prompts, because I experiment with lots of different models, these models have sort of different prompting styles that they enjoy. And I guess specifically with Claude, what it expects or for improved performance, but what you should always have there are any text. So is a tag that signifies that it's text that you're saying versus text that the model has generated. I refer to these as sort of human tags and robot tags, but really they are sort of user input should be prefixed with human, and then a model generated text should be prefixed with assistant. And when I show the prompts, you'll sort of see how this is used. But it's really when I'm attempting to tell the model that it should generate text. But additionally, if I want to start to put words into the model's mouth, and you'll see what that looks like. Then there's actually invoking the model. Nothing major here. I have the client, which will be, in this case, the Bedrock runtime client that I initialized above. There's the endpoint, so which model am I actually using. And then there's the payload, and the payload has the prompt in it, as well as, oh yeah, I think it shows it here. So it has the prompt, as well as any parameters that go into the model. So things like temperature, top P, the max tokens to sample or max tokens to generate. And then I am calling the Bedrock. I'm calling the Bedrock service, right? So a lot of this other stuff is just error handling and extraction. But in the call Bedrock, so the same sort of setup. So there's my client, there's my body now instead of my payload, and my endpoint. And I'm just retrying this, just if there are any errors. So some error handling pieces. But the client, I just use invoke model. An invoke model just takes my body, so essentially my prompt and parameters, the endpoint, which is called the model ID here, and then there's some information on accepting and content type, which will essentially always be JSON. So that is what I'm using to interact with the Bedrock service. So now we get into, I'll call them auxiliary functions. So functions that they perform a role, but they're not sort of germane to the application. So things like uploading data to S3, right? And if you'd like, I can go deeper into what these are doing, but essentially there's a file, there's a bucket, I'm uploading that. Additionally, I download from S3 as well. And this is useful if you have PDFs that are stored in S3, those get downloaded, but other files can get downloaded as well, like audio files can get downloaded from S3 as well. I can list PDFs, that's great. I can extract PDF text, so this is going to eventually use the text extract service to then extract the text from PDFs. And additionally, so the audio or the podcast was generated with Amazon Polly. So Polly has a number of tags that are supported. So things like pausing in between sentences or paragraphs, as well as controlling things like, let's see here, how to pronounce acronyms, or improving pronunciation. Lots of interesting tags. And so I want to make the model aware of these because it may not have all of that context. And so there's a poly tag examples function. Additionally, there's a get poly tags. So one thing that I have experimented with is passing in sort of entire documentation, right? So this is basically a text version of the Amazon Poly documentation versus just passing in my sort of summarized version. And so now we get into actual prompts and text generations. So another thing that I didn't explicitly mention, but is part of this, is that I do extract metadata. So I've gone sort of back and forth on this. There's no way to manually input metadata, and so I just automatically assume you're passing in a PDF. Uh, we need to extract that metadata as well. And so this that will extract metadata, and I'll talk about this a bit, but for all of my calls to Bedrock, they'll have a similar form. So first are any of the tags that I need, right? So this is for the model that I have, right? I'll have a certain type of human tag or user generate or user text, and I'll have a certain robot tag. That's the model generated text prefix. But from here, I'll have my prompt template, and it's broken up into what I'll call the pre-prompt. And so this will be any persona information or role-playing information. You're an AI researcher whose goal is to analyze articles and extract requested content. Pretty simple and straightforward. Then we get to the actual instruction. So what I'm telling the model to do is read the following article and extract, and then there's a list. So the title, and I give just a statement about what that is. Then 2 is the year, because I also want the year for this. 3 are the authors, the author of the article if presented. 4, the categories, and this is really useful for sorting, storing, and organizing, right? So just a list of categories that are inferred. And then I pass in the article itself, and I'll usually wrap input into XML tags because that's what Claude is really proficient in. And then I have a variable here that's input paper. So if you're familiar with things like LangChain and other libraries, they'll usually have some sort of format that they work well with. I mean, even Python itself has a sort of format option as well for dealing with strings. I just use a keyword that I know, and then what you'll notice down here in the prompt is that I just replace input paper with that variable that is the paper. So after that, I have my sort of post template, and everything here with sort of the post is happening after the user provided text. So the human text starts the prompt. Then I have any instruction or detail that I'm giving the model. So you're an AI research assistant, as well as read the following paper and extract all of that information. Following that, I'll have the robot tag. And so this now signifies that now the model is generating this text. And so here's where I start to put words into its mouth. So first I wanted to respond in the affirmative. So sure, here's the extracted information. There's a typo there. Excellent. With the correct title, year, authors, and categories is a valid JSON. Okay, great. I'm telling you I want it to output a JSON. And then I have the end. And where the end is really useful is for formatted output, or where I use it a bunch is for formatted output. So I'm saying I want this to generate JSON. What this end is designed to do is just start that JSON in this case, right? So I'm starting the JSON, the curly brackets, oops, the quotes, title, and then stop there, right? Really increasing the probability that I'll get the output I want, right? Increasing that it'll be in the format that I've requested. And then I put all of that together, right? So my human tag starts, I have my persona or my role, I then have the actual instructions. Now it starts the output of the model. I have the response of the model, or the initial response to the model, and then I have the start of any formatted data, right? Following that, again, I replace the input paper variable with my actual full text. So I'm just passing in the full text wholesale. And following this, I'm just getting everything set up to actually invoke the model, right? So those functions above that call Bedrock, I'm just setting that piece up. So my payload, I set my prompt to be the prompt that we just formatted and created, and then I'll get the response. So I'll invoke model, get my response, and now I need to extract some information. So first, because I know this is a JSON, I need to turn this into valid JSON, or I'm going to turn this into valid JSON so I can extract the variables. And so that will be me placing sort of my template end, right? So again, the start of that JSON, and adding that to my response. And then just in case, so sometimes these models will produce my JSON in this case, but then they'll actually make some statements at the end, and I'll show you an example of this later. And so to just trim that off, I'll just split by the closing brackets and then add that back, right? So this should be sort of one open bracket, close bracket, JSON, valid JSON. Then I'll use the JSON library to load that. And now I can start to, or now I should be able to at least, extract information like title, year, authors, categories, etc. Additionally, so although most of the podcast or most of the audio session is generated by a model, for things like for the metadata, it's standardized. So for example, in the titles case, so I have the title, the poly version of that title will just be the title of this paper is, and then we'll just put the title there, right? No need to complicate things if I don't have to. And so I can say how I want the session to start. Similarly for the year, similarly for the authors and categories. And then all that information is returned. One thing I'll note, just because it's part of the actual implementation, something I noticed is that calls to these models sometimes take a bit of time. In order to sort of parallelize that, I've turned calls to the models into separate threads that call asynchronously. Because of the way I'm returning things, if I am using the threaded version, I just pass in a queue that then I will put any of the information into and then extract later. So I'm actually going to come back to this one. So this is a call that I'm making to then get the podcast. Oh, okay. Let's talk about it now. So this will be the same thing. I want to get a podcast version of a summary. Right, so I get the paper. I'm actually passing in a paper summary, and I'm turning that into a podcast. So again, the same setup. I still have my human and robot tags, so my user-generated text and my model-generated text. And then from there, I'm going to have any role information. Here it's just blank. I didn't feel the need to pass that role. And here's where we get to my instructions. So the following paper summary will be passed to Amazon Polly to be turned into speech for podcast audio. Read and rewrite the summary to be read by a speech-to-text service. Right, and this paper focuses on, as an example, use the relevant Amazon Polly tags. And so I have input Polly here, and this is where that previous function providing the Polly documentation comes into play. And then I'd say, from the above text, adapt the summary to be read by Amazon Polly, and then I'm giving the summary here. There we go. I found that variable, and I give it some more information. So this is all the detail. So now we get to where I'm putting words into the model's mouth. Right, so sure, happy to help. I'll convert the paper summary above, following these guidelines, and then I'm actually giving it guidelines I want it to follow, and I'll show how I sort of arrive at this later as well. But simplify language and define terms, avoid complex academic jargon and industry-specific terminology, blah blah blah, etc., all the way down. And these are my guidelines. And then finally, we get to the end, and here's where I'm getting formatted output back. Right, so I'm going to have the tag summary Polly, and so a requirement for Polly is that you begin and end text in the speak tags, at least for SSML. Okay, and then we have the same setup we had before. Our prompt is then the human tag with our user provided text, then the robot tag with our robot provided text with our model generated text, and then we'll replace any relevant information, any variables that we have there. right? We'll then invoke the model, and then we'll get that summary back. Right. In this case, I'm not keeping the sort of summary, poly, and speak pieces. I'm splitting off the ends. I just want the transcript. I don't necessarily need the surrounding tags. Okay, and so now we'll do something similar with generating the summary. So setup is still the same. Get the sort of robot tags or the model tags that we need. There's no role here, but we are saying read the following research article and write a detailed summary. Right, and I'm giving it additional instructions. Be verbose and explain these concepts well. Define any uncommon terms. This should go above and beyond the abstract, blah, 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 blah. Right, so a lot, some useful information there. And then because I want sort of structured or wrapped information, I am passing in a summary tag. Right, still invoke model. I still get back the response and then split out it from the summary tags because I just want the summary. And then I return that information. Now, what you'll see here is that unlike the metadata function, I'm going to generate an audio version of this summary, right, which is the function we just saw above. For that, I'm just passing, again, the client endpoint payload information along with the summary into that function, and it'll return back the audio transcript. And now sort of the last piece, or the last sort of notable call to the model is the generate code example. Same setup. You're an AI researcher whose goal is to analyze articles and provide robust and understandable Python code examples. Great, I love Python. Read this and provide well-documented code, etc., etc. So I have my input paper. I'm giving it details on how I want it to implement the code, and then I also give it some, put some words in its mouth, right? So certainly I will write a well-documented and error-free code. I'll also detail all my functions. My outline is, and then so I'm asking it to also make an outline, right? So I want to get it into that chain of thought prompting paradigm where it's going to first give its outline and then generate code. And then I start with a numbered list, right? From there, the same thing as before, human tag, robot tag, replace the input paper, invoke the model, right? And in this case, I'm splitting the code out in between code tags, which I believe is here. Yep. So I tell it to use code tags. So I'm just splitting out the code in between that. And those are the functions, right? So not very large or complicated prompts, just some writing, essentially. Now, so one thing I do sort of really require, especially when I'm building applications that someone else might use, is consistency, right? So it's not enough for it to work once or twice or three times. I really want it to work on a consistent basis. And something that I noticed, especially with the tags for Amazon Poly, that sometimes it wouldn't provide closing tags, or there would be something missing, or there was an unallowed tag produced. So the sort of first line of defense here is another call to the model to try and fix any potential errors that it has there. And so for this, again, I have my tags, and then I have my prompt, read the following text, prepare for Amazon Poly, and correct any errors in the SSML tags, right? And then I provide that input text and some supporting instructions, and there we go. And then I pass it to the model or invoke the model and then return that result. I've seen this improve consistency a bunch, and it's something I will sometimes do, especially if I need really well formatted text consistently, is just have a function that's designed to catch errors. You might say maybe I should just do better prompting. Yes, I should, but adding an extra layer I have seen help a bit more than spending much more time on the sort of first round of prompting. right? Almost like a diminishing return, right? So I can get a pretty good prompt in relatively little time. I can get a very good prompt in a bit more time, and to get a very very good prompt takes a lot of time when I might just be able to add a second layer or a second level of processing if I really need. From here, there's just some more calls to functions, right? That are sort of auxiliary. So in this case, I have some text chunks that I'm passing in. It's really the poly version of the summary, the title, the authors, the categories, the year, etc. And I'm just parsing it. All right, so nothing crazy here. I'm just making sure it's in sort of pause tags and sentence tags, as well as having the required sort of speak tags so that it's valid. And then here we have the synthesize audio function, which I think you can imagine what that does. But we're calling the poly client to then synthesize speech. And there's some error handling here, just in case there are. So there are certain reserved characters for Amazon Poly. So like ampersand, single quotes, double quotes, those sort of things. So if those are in the generate text, they need to be removed. And this is just a function, setting all of that up, right? So what this also does is essentially splits up the podcast into sentences, more or less. It's not necessarily sentences, but essentially sentences. And then it will process each of those sentences or get the audio for each of those sentences. And then I'm just concatenating them all. There's some save output that sends the necessary information to the correct S3 bucket. There's some functions for interacting with DynamoDB, right? So there's performing a table scan of the items. There is just getting a specific item. I'm sorry, yeah, getting a specific item. And then there's placing a specific item into the table. Okay. Those are all of the functions. Everything after this, okay, and I'll talk about this process was really the main function that calls each of these. But everything after this is mostly Streamlit functions, and well, I'll talk about them a bit. I'll skim through them, but I am not a Streamlit developer, so don't use my implementation as sort of law. So all that the process paper is doing is, again, it's running those threads for get paper metadata, get summary, get code. And additionally, it's then extracting that information back. And then we are using the needed services, right? So, text to speech, split the text, another text to speech call if the other unfortunately messes up. And then we're saving output. Right, so we want this to be available if we want it to reprocess or get any of this information back. So we're saving the text, the transcript, the audio, the code, etc. And then this item here, this JSON object, is placed into DynamoDB. And we're done, right? So essentially 3 calls to the model. So metadata, the summary, and the audio, with an extra one for fixing some mistakes. And there we go. As well as here's the sidebar. So again, these are the Streamlit application, or Streamlit components. So I have a sidebar. There's some caching of papers. There's actually running the application, and the code will be available. So please feel free to take a peek at those, but they're not the most important piece, or at least the piece that we're really interested in right now. And then a lot of UI control pieces. Which look like a lot, but they're not actually, right? And then down to the actual main function. It's then pulling in the config file that we set up, and then initializing the application, and then running the sidebar and running the application. And we're done. And that gets us here. So there's the application. So there's sort of 2 other pieces that may be worth mentioning. I'll show you the S3 bucket as well as the DynamoDB table, which might be interesting, but that aren't sort of super important. And then I'll show a bit on my process for prompt engineering. So first, let me go to S3. And of course, I'm super zoomed in. There we go. But my buckets, yeah, here we go. The research assistant bucket just has a data folder or data directory, and then there are my PDFs and any PDFs that you upload. And additionally, there's, well, okay, audio's one. So all of the MP3s that we have there are here that you can then use in other applications and all of that information. So the information is really stored here. But additionally, Dynamo has a ton of metadata. And let's look at some tables. So we have the research assistant document, but we can explore items is what I meant to look at. Okay, and so we'll see there are all of the paper names of any of the past papers that we processed. We processed 50 papers. There's a process timestamp, which is just a year. And this paper name is the index, the unique ID. And then there's also a sorting ID. And so that's the process timestamp. So both of these you will need if you're implementing yourself, but everything else gets implemented on the fly. One of the neat features of Dynamo. So audio location, if I just open this up a bit more, just has the S3 location of the audio. And so this is really important if you use different locations, right? Depending on, right? So these are all in the same location. So there's no real need for me to have this. But if I started storing documents or audio in another location, then I could leverage, where it's stored here. There are the authors that we can do stuff with if we'd like, just a JSON list. Additionally, there are any categories if we want to do any sorting, artificial intelligence, machine learning, mathematics, optimization, financial statements. Okay, interesting. I do store the code location as well as a text version of the code, which is convenient. And then we have the model that we used. And so again, this is that endpoint that we showed in the config. We have the full text location, the paper location, a lot of other useful information, but this is really the metadata that we're storing. And those are all of the services that we have to stand up. So what is it like to prompt engineer, or what are the process that I generally use to prompt engineer? And for that, I'll go over to a test bench that I've set up. And here, scroll to the top a bit, is where I do a lot of my testing. It's just in a notebook, trying out different prompts, seeing what the outputs are. I'll show, I think the code one is what I have set here, as well as what the podcast transcript looks like. And I have the imports that I'm using, as well as sort of my standard functions. So, get model tags is something I always have there. Query endpoint is something I always have there, except with a couple of additional models that it supports through the Bedrock service. And then I have the actual call to Bedrock. I think in another video I may go over using some of the SageMaker endpoints as well, because they work in a similar way, except instead of a call Bedrock, there's a call SageMaker. But most of this is the same. Most of the structure is the same. Additionally, I'm setting up sort of payload and endpoint information. So I'm giving a timeout to the service itself. I'm creating a client. I'm setting my endpoint sort of manually in this case. And then I'm setting my payload, right? And I'm increasing the max length of the tokens that I'll accept. My temperature is at 0.75. I may play with that a little bit in the future. But if we look at my directory for this, I have some text papers that I have uploaded. And this is really, right, if I'm testing out my ability to get good generations, I don't need to reprocess the same PDF a million times. So this is just for convenience. And so what am I doing, right? So I do a slightly different here, or slightly shorthand, but I still have my human and robot tags, so that'll always be there. I'm just being a bit more explicit. Instead of saying I say persona. You're an AI researcher whose goal is to Python examples, right? So the same as before. I have sort of prompt instructions. So read the following research paper and implement it, blah, 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 in well-formatted code. I have my paper. So that piece is the same. But here's where I start to deviate a bit. Right, so I give details. So follow these steps when writing code. Read the paper thoroughly. Don't just skim and try and code. Draw diagrams, explain, identify key components, etc., etc. Write tests, and then give it a sort of in summary. Here, I'm not giving it any. I'm not putting any words into its mouth other than I'm starting with code in the brackets, right, or the code tag. And then I just loop through this and test out what the code looks like when it produces something. I'm not sure which paper this is. Selective state space model layer. Okay, so I think this was, so recently, or relatively recently, there was a paper Mamba on state space modeling that showed, I would say, impressive efficiency relative to transformer layers. And so that was something I was really interested in. And so that's what this paper is. And so this is an implementation of that. All right, so we have the class, initialization, the forward process. There's a scan function for these, as well as a Mamba block. Yep, okay, the Mamba paper. And then the end of the code. And so here's some of that narration from the model that we sometimes get. So the reason I use tags is just to get the relevant pieces, but this implements the core selective SSM layer from section 3 of the paper. Okay, some useful information there. It also gives some key points. I like that. And my takeaway from this is really that the prompt details were pretty good. I did some tests where I didn't have these prompt details, and the results were not as detailed, I guess, as well say. And this is for the other papers that I was looking at. But I had an idea to try something a bit different, right? So really it takes place here in the post and end, where these instructions are still the same, but now I am not going to limit it to starting with the code tag, just to see if that affects the reliability. And so I just allow it. So now it can give me some narration before giving me actual code. So here's an example implementation of the selective state space model architecture from the paper in PyTorch. It focuses on clear documenting and explaining the components rather than being optimized for efficiency. Okay, reasonable. And so again, we'll have our selective state space model, right? The initialization as well as the forward pass, some helper functions, selective scan. Okay, so they place that into the class itself, and broadcast. Okay. And then the code stops, right? So the key components, A parameter, B, C. Okay, so some useful information here as well. I will say this was maybe a bit less expressive, so maybe it's a more complete class, but I wanted a bit more information. Right. So in allowing it sort of that freedom of when it would respond, I didn't get quite the detail I was looking for, although this class seems reasonable. So let's go a bit further, and I was sort of using the XML code tags because I thought those might be more in line with the way Claude was trained. But seeing how it produced sort of the markdown Python code, my thinking was, okay, maybe it's more comfortable producing markdown code instead. And so all of these pieces are the same. I actually did change and didn't say use the code tags. And now I do put some words in his mouth. So I just start a markdown Python code block, and I start with a uh, string or a comment just saying detailed description, just to see if it would be a bit more a bit more detailed. And let's see what we got here. Okay, so this code implements the core selective space-based model described in the paper, including the efficient fused kernel for training. It allows parameters. Okay, some useful information there. I have the 6 layer. Right, so we have the forward pass. There are helper functions, selective state space expansion. There's the Mamba architecture itself. Right, so using the S6 layer. Okay, reasonable. And then the forward pass, selective copy task. Okay, I need to do a bit more here. But then something that I do like that now I'm remembering is that I have a model that is the Mamba model. So it's giving me an example implementation of how you might use this. Getting the baseline parameters, and then how you might, I think it was how you would train this as well. Oh, okay, so it didn't go all the way through. Just various implementations, and then printing out some pieces there. The code demonstrates key ideas of the paper, success model, Mamba architecture. Okay. Debatable how well I like that one, but this is generally the process I go through in trying to determine the best way to elicit more information from the model. Let's see, did I do another? So I didn't do another round, but then I sort of switched to try and optimize or perform some prompt engineering for the podcast generation, right? Which is another area where I really was looking for something closer to 10 minutes as opposed to 2, which was I think the average of what I've seen so far. And same setup, human tag, robot tag, no persona here. And I go back and forth on whether I think the persona is useful or not. But my instructions: read the following research paper and write a podcast. And so one of the big changes here was that instead of, so in the application that you saw and in the function that I showed, I was using the summary to then generate the audio. But in this case, I'm saying, well, what can I do if I use the full text, right? The full paper to try and generate a summary. So that's was the exploration here. And additionally, I provided some prompt details. I'm a big fan of providing sort of details to the model to follow. So carefully read and comprehend the research paper, outline key sections, etc., etc. And then finally, I have tags that are podcast script. I started with one where I was thinking maybe I would start each podcast the same. So there would be a presenter. Yeah, here we go. There would be a presenter and a guest, right? So give it a bit more dialogue, a bit more back and forth, and give them separate personalities. And then I have the presenter say, "Hi, I hope you're doing well. The title of today's discussion is," and then just let the model deal with the rest. So let's see what we got here. So we got the podcast script. "Hi, I hope you're doing well. The title of today's discussion is," and so here's where the model is actually generating information. So Mamba, linear time, sequence modeling with selective state spaces. Okay. To dive into this, I have with me my colleague who's an expert in the field. Welcome. Please introduce yourself to our listeners. Okay, so it started well. It's giving a back and forth. So I have the guest. "Hello, everyone. I'm thrilled to be here. My name is, et cetera, et cetera." And then it goes through in this presenter guest guest dialogue for a bit. I get a fair bit of text here. I think this was closer to 4 minutes or 3 minutes. Not my sort of 10 that I was reaching for, but a decent amount. And the text looks good. They talk about key ideas. So again, not just giving me a text representation, but giving some color, right? So giving some creativity, giving a bit of explanation to go along with the actual information in the text. But it wasn't perfect. And what I found on successive runs, let's see if I can find one with another paper. Not this one. Not this one. But sometimes what I would see happen is that, so again, what I'm always looking for as well is a way is that I have to parse this as well, right? I can't just use whatever text was popped out and pass it into Amazon Poly. I need it to be sort of really finely tuned, really finely formatted. And in this case, my thinking was, okay, I could use the presenter to always be the presenter piece, and then it always alternates to guest, and I could then extract this text. What I found was that sometimes the variability of these models. So sometimes when the guest would introduce themselves, then in subsequent sort of dialogues, they would have a name, which sort of completely stopped me from being able to use this method because I can't reliably parse whatever name is mentioned here and then use it. So I needed something else. I tried a couple of different approaches. So in this case, the presenter and guest, give them separate personalities. An episode should last 20 minutes, etc. And then I still kept the I hope you all are doing well component because I didn't see any faults with that yet. And so then we continued, right? So still Mamba, linear time, stasis modeling, introduce Albert. Albert's an expert in the field of machine learning, neural networks. Okay, great. Then they have this discussion. The text is longer. And so now we're up to roughly 5 minutes. Not the sort of 20 minutes that I mentioned there, but definitely more. And so here I got more text, but let's see if I can actually find where it did that. Another, let's see here. Guest presenter. Oh, okay. And so here's a case for another paper, re Laura, but there wasn't as much. So it wasn't super consistent across papers. So I needed to work on that. And in this case, so I drop it all together. So write a podcast. I drop the presenter and guest because of the unreliable nature of getting presenter and guest all the time. I still wanted it to be close to 20 minutes. I think the model isn't able to accurately sort of understand this or generate that much coherent text. And then I made some updates to the prompt details. And so I have this one open. So now it's a single person, right? So hello, hi. And additionally, I dropped the whole intro dialogue just to add variability in how the podcast starts. But I still start with the podcast script tag. Hello and welcome to the AI Research Review. Okay, the podcast that breaks down the latest in artificial intelligence papers into understandable bites. I'm your host, Alexa, fitting name. Today we're discussing an exciting new paper from Carnegie Mellon, Mamba, linear time sequencing modeling with selective state spaces. Okay, great. And then it goes into a lot of information here. There's maybe not as much text, but it gives some detail. And now I'm able to more effectively parse, right? So I don't need to parse it into two speakers. It's a single speaker, and this will go a long way to help me deal with that. And then finally, I sort of switch it a bunch and say, well, maybe in the same way that I had that secondary function to fix Amazon Polytext, maybe I should have a secondary function that read the following podcast script and write an extended podcast for it, right? So the idea is, okay, the model was able to give me a first draft of what that podcast should be. Now let's take it to the next level. So let's try and create an extended podcast that builds on what was there before, right? So I'm still passing in the paper because I want that as context, but now I'm passing in the initial script, and this is what I'll call it in this case, an initial transcript. And then from that, I'm going to create a new one. I still have my following details, except these details are specifically for expanding an initial script into a detailed script, right? So it would be identify the key topics and themes in the short script, make a bullet point outline. These will serve the framework, and then for each main point, brainstorm additional details, examples, etc. Blah blah blah. I think my next line of work will be in looking at how effective these details are. So sometimes telling a model to read something, I think can help it produce more reasonable text. Unclear how far that extends, right? And then I always end with the podcast script piece. And so from that podcast above, or from that transcript above, I now have this, which is much more in depth, is closer to 7 minutes, right? Which is really good. Hello again, my curious AI listeners. I'm Alexa, and welcome back to the AI Research Review. Last time we explored inside neural network, etc., etc. Today, I want to go much deeper on how Mamba works, its magic under the hood, right? And there's just maybe not a ton of information, but a good amount of information here. And so I'm thinking this might be a good effort. The other thing that I need to balance though is the amount of time it takes to process. So right now, with sort of the stripped down view, I think it took that paper roughly, so it was 20 pages, and maybe took it about a minute, 2 minutes. I really want to get that down, and any additional call to the model may add another 30 seconds or 20 seconds to that, which starts to get a little outrageous. I think for short summaries, 40 seconds is doable. Right, you can process a substantial number of papers if each paper processes in 40 seconds. When we get to 5 minutes, though, really the summary and the usable information needs to be very detailed and very targeted. So I'm still working on sort of balancing that, but the idea might be maybe there's an expanded mode or a detailed mode that then gives you sort of a really in-depth review of the paper, but sort of is designed to sort of work in batch, maybe, right? So you dump a bunch of papers, you let it run for an hour, and then you have access to all of those papers. Still working on that piece. And then I brought in the call poly function just to see what that turns into. And here's that podcast, then turned into speech. So with that, I hope I have given you a little insight into how I try to build generative AI applications. In addition, if you're interested in this, will make the code, or the code is available. Check the description. So I make the sort of notebook that I use for it available, as well as the individual code. And then the test bench notebook will also be available. So I thank you. Have a great day.